Alright guys, welcome to lesson number 2 on computer memory. So this is kind of where we left off before. We had 6 memory slots just like this, and I'm just going to go into a little bit more detail about how the computer uses and sees this memory. So as you already know, we have slots of memory in the computer memory in the RAM. By the way, RAM stands for Random Access Memory, and what that basically means, or the way the computer uses RAM, is that is where the computer stores things sort of temporarily while the computer is running. So, for example, you're probably familiar with a hard drive, and you might even be familiar with like a thumb drive or a solid state drive, external hard drive, etc. That's not RAM. That's something else. And what that is that allows people to save files permanently onto the drive and shut the drive down, and it's still the files are still there. So RAM's different. The way RAM works is that when you shut the computer off, the RAM shuts off and it gets cleared out and everything. And then when you reboot the computer and turn it back on, it goes and gets stuff off of the disk, basically. Or when we say disk, obviously we're referring to any type of what they call persistent storage, which again would be like hard drives, solid state drives, etc. So it gets the information off of the disk and then it loads it back into RAM. So RAM is basically like short-term memory, and that's what we're talking about here. So the way the computer stores stuff in these slots is just like this. Each slot has an address number, right? And the numbers are longer than this because there's way more slots than 6, but this is the same logic. So each slot has a space for information and an address number. So for example, let's say your name's John, and I said, hey John, or Jane, I want you to take and I want you to put 5, the number 5, inside slot 1, and then I want you to take and put the number 4 inside slot 2. And then what I want you to do is I want you to add whatever is inside of slot 1 and slot 2 together, and I want you to put the result of that addition in slot 4. So what you would do is you'd be like, okay, well, 5 plus 4 is 9, so I'm going to put 9 in 4, right? So this right here is how the computer processor actually does its work, essentially. It's got a whole bunch of slots of memory, and they're not just in RAM either. I'm going to explain that in a second, but it's got a whole bunch of slots, though, of memory, and what it does is it pulls information out of these slots, it does some operation on that information, and then it returns some information into a slot again. So if you think about it, you could do pretty much anything like that. You could do any type of math or anything. Like you just like what happened right here. We had a 5 and a 4, and we said, okay, we'll get the 5, we'll get the 4, we'll perform addition on them, and then 5, 4, add them together, and we got 9, right? And then we put that 9 down here. So this is a very similar. This is how pretty much how the CPU works, except what we're doing here is a simplified version because we're doing all the operations in these slots right here. Whereas what the CPU does is it has one more set of slots, which I'll show. I'm going to change colors here so we don't get confused. So it has another set of slots over here, right? And these slots are actually in the CPU itself, and but it's very similar. Let's see. So I'm not going to represent them all because I'm just trying to get the idea across. But these slots here are called registers, and we'll just say that they're called EAX, EBX, ECX, EDX, and EDI. We'll just say that, all right? So you're going to notice something very similar here, right? So both of these groups here are slots. they both can hold information inside their spaces, right? Because we can hold stuff in here just like we can hold stuff, just like we held the 4 over here. We can hold stuff in EBX here, right? And they also have a unique identifier, right? So EAX is different from EBX. EBX is different from ECX. So instead of having numbers to identify these slots, they have these letters right here, these names, okay? Sort of like when you talk to your friend Sarah or Connie or Doug, instead of calling him or calling them 1, 4, and 5, right? But they're still unique identifiers, unless you have like 2 Dougs, but let's just pretend that doesn't happen right now, right? So what the CPU does is, let's say you want to add 5 and 4 together like we just did here. Well, it says, okay, well, let's take 5 out and put it in EAX. And now let's take 4 out and put it in EBX. Now let's add EBX plus EAX, and that is, then we're going to place the result in 9, or in 4 over here, which the result is 9. Excuse me. So it doesn't, so the CPU can't work specifically only on memory, only on RAM memory, right? So what it has to do is it has to place something inside of these registers, and then it has to do an operation with at least one of these registers as an operand. So what it can do is, it can do, for example, it can do EAX, or the value in EAX plus 1, right? So, and what I mean by 1 is I'm talking about memory space 1, right? So this would be, so if we had, let's say we had the number 4 inside EAX, and then we want to add 5 to it. So we could do EAX, which is 4, right? So we have 4 in here. That was a terrible 4. I'm going to redo that. Sorry, I'm getting used to this pad here. Okay, so it's still a pretty bad 4, but just bear with me. So we have 4 here, and we want to add 5 to it. So we say EAX plus memory slot number 1, and then we'll get 4 plus 5, right? And then that's how we can get our 9. So this is the same type of thing that's going on inside the computer at all times. This is what the processor actually does right here, okay? And it's basically it. Like, it just does a whole bunch of different operations. It has add, subtract, multiply, divide, which can actually be done with just, it can basically be done without even having to multiply and divide in the way that we usually do. But it can do those things, and it can do other operations as well. It can move things around. Like I said, it can move like a number from, ECX into memory slot 5. So it's starting to look pretty messy. So I'm gonna go back to where we had our clean slate here real quick, because it's starting to get kind of messy. So yeah, so the computer, this is how the computer does everything. I mean, this is it. This is what the computer does. It takes information and it puts it inside of slots, and then it takes it out of those slots, reads it, and then it performs work on it. That work could be addition, it could be subtraction, it could be multiplication, it could be division, it could be other more complicated operations, which are just basically a combination of those things that we just said. And so that's why it's critical that you understand that every single one of these spaces in memory and also in the processor, every single one of these spaces has a unique identifier and a spot for information to be stored. And when I say information, ultimately I'm just talking about numbers, because that's all the computer really knows and can work with, right? So in other words, for example, the letter capital A on the keyboard is actually hexadecimal number 41, which you may already know depending on what type of programming you've done, right? So this is, even letters like this right here, like A, are actually just stored as numbers when it comes down to being stored in memory, right? So that's an important concept as well that I want you to know. And I'm going to wrap up pretty soon so I don't drag this thing on too long, because this was already quite a bit to absorb, and you might want to go back and watch it again if you need to, or do some further research on Google. But So the last thing I wanted to talk about is that you can basically store. So okay, so let me just put it this way. You can store. You know that you can store information inside these slots, right? So let's say I wanted to store where the 5 is inside of 6, right? So what would we put inside of 6, right? Well, we'd put the 5 is at here. Let me change colors again real quick. There we go. Put it back to blue. So the 5 is at memory location number 1, right? That's where the 5 is. And you know what? Just for the sake of not confusing, I'm going to put the 5 down. I'm going to put it here because that would be really confusing if I was talking about a 5 inside of memory space number 5. So the 5 is in space number 1. So do you understand the connection here? So we have a piece of information, which is an integer, which is the number 5. And it is being stored in the address number, in the memory location with address number 1. So if I said, hey, Johnny, I want you to go get me the 5 out of the inventory inside of the pantry. What Johnny would do is Johnny would run over here and he'd be like, okay, well, there's nothing in slot 5, or there's a 9 in slot 4, there's nothing in slot 3, there's a 4 in slot 2. Oh, here's the 5. The 5 is in slot 1, right? So Johnny would get this 5 out and take it out of here, out of slot 1, right? So what if you ask Johnny, hey, where was that 5 at? I want you to take the location of where that 5 was, and I want you to put it inside of slot 6, right? So Johnny would go to slot 6, and he'd put number 1 in here because the 5 was at location number 1, right? The 5 wasn't at location number 5. Location number 5 has nothing in it. And 5 itself is the value, but the space that the value is being stored was in location number 1. Okay, so we're going to put location number 1 down here in 6, right? So congratulations, we just covered what pointers are. Okay, so location number 6 is a pointer, and it points to location number 1. So location number 6's data, or its value, is the address of another location in memory, which is location number 1. So number 6 is a pointer. Okay? So if I said, hey Sarah, I want you to go to location number 6, and then when you get there, there's going to be an address of another location in there. I want you to then read what that address is, and I want you to go to that other location, right? So Sarah would be like, okay, well, I'm going to come down here to number 6, and oh, well, it has the address number 1 in there, so I'm going to go up here now, and then I'm just going to wait for further instructions, right? So she would go to space number 6, like she was told, find out that the address inside of space number 6, being stored as data in there, is the address of space number 1, and then she would go to space number 1, right? So that's what a pointer does. That's all it is. So instead of having its own just integer or floating point number in there, instead it holds an address, which is ultimately a number, right, of another spot in memory. So that's all I want to cover today because this could get way too complicated. Once again, I'm trying to keep this in bite-sized chunks. So thanks for watching, and I look forward to doing the next video, and we'll talk about this stuff in a little bit more detail, as well as cover related subjects.